Oui, donc il va être question de deux logiciels en fait de traitement de données sonores. Un logiciel qui s'appelle Ipstas et qui donc traite, a été utilisé sur des enregistrements sonores de UPenn Sound. Et un autre logiciel utilisé par un groupe de recherche de l'INA et qui là analyse la parole de poètes lisant leurs œuvres mais dans des émissions de télévision. Les deux intervenants sont Tanya Clement, qui est assistant professor à l'école d'information de l'Université du Texas à Austin. Donc Tanya Clement détient un doctorat en littérature anglaise et un MFA en fiction. Sa principale thématique de recherche est centrée sur les structures d'information scientifique et leur impact sur la recherche universitaire, sur les bibliothèques de recherche, la création d'outils de recherche ainsi que des ressources dans les humanités numériques. Tanya Clement va nous parler donc de cet outil d'analyse des données sonores qui s'appelle Ipstas. Et Monsieur Jean Carive donc fait partie et responsable adjoint à la recherche et à l'innovation à l'INA. Et sa communication portera donc sur la parole dans les émissions de télévision consacrées à la poésie, dont il y a beaucoup d'archives à l'INA. Voilà, donc d'abord nous allons donner la parole à Tanya Clement.
Thank you, and thank you for the invitation to come. This is very exciting. I'm one of those people who left family behind. In fact, it's funny, I have 3 children, and over the summer when the invitation came, I said, what do you think about me going to Paris over Thanksgiving instead of being with you for Thanksgiving? They said, yes, that's awesome, you should go to Paris. And then their father came home later that day, and I said, I got this invitation to Paris. He said, well, you can't go, the children will be very upset. I said, no, I asked them, they're fine, they're very excited. So thank you for the invitation, and I am not displeased by not making mashed potatoes today. So I want to talk a little bit about this project that is called Ipstas, High Performance Sound Technologies for Access and Scholarship. And I want to begin with a nod to Charles, in part because he is very much an inspiration for this work, and he and Al, by answering my letter, essentially facilitated some of the early funding by giving us access to Penn Sound and giving us a collection with which we could sort of explore some of the things that I'll talk with you about today. So this is a public thank you after very many private thank yous. So one of the things that I was intrigued about in terms of using sound files, so I come very much from a digital humanities background. My work in digital humanities started with text files. I worked very closely with Stein in using computational analysis to think about what Stein was doing and trying to read Stein in new ways and contributing to literary arguments about Stein by using computational methods. And also worked with the Baroness Elsa von Freytag-Loringhoven, who Al and Charles are very fond of, as well as others who spent some time here, died here in Paris. And wrote my dissertation on both of those people, Stein and the Baroness, thinking about what it is that we're doing when we do literary analysis by computational means. And so moving over to sound for me was a way of continuing to explore those kinds of questions. Some of those questions become, what does it mean to study culture through sound recordings? Is it fundamentally different than studying culture through text? What do we learn from those differences? How do we articulate this acoustic experience that Charles talks about in the context of digital audio to ourselves, to our students and colleagues, and to our machines? A lot of the work that we do in digital humanities is what does it mean to model what human beings do in a computational environment? Those are the kinds of research questions that are the most salient for me in the context of digital humanities. And what impact does the digital experience of such acoustics have on how we access and understand our cultural heritage? So this idea of preservation and distribution is very dear to my heart, and primarily because one of the big findings by some of the national studies in the United States is that we do have this cultural heritage in sound that is dying on old formats, and it is of immediacy to digitize them. But in the context of digitization, it's not clear to the people who are doing that digitization and preservation and how the world, scholars, students, the public want to use these sound files. So that work has to happen simultaneously, so that the notion of distribution as preservation isn't only that multiple copies out in the world mean that these things will be preserved, but it also provides for more opportunities for us to understand how are they going to be used, right? Computers are very based on textual models of the world. Computers are very good with words. And as human beings, we think we are very good with words. You see a word, and although literary scholars, we should know better. We don't know what a word means just because we see the word, right? But we think we do, and we think we can model that in a computational environment. It's much more difficult when you get to something like sound. What is it that you're actually preserving? What are you actually giving to people in order to allow them to do the different kinds of research that they want to do? And I'll give you examples of that in a moment. So this project, sorry, the color is a little bit off, started with an advanced institute in technologies funded by the Digital Humanities Office at the National Endowment for the Humanities, and very much started with the initial idea that my team here, constituted of a variety of different kinds of people, could put machine learning tools and applications in front of people like poets who are already well versed in pen sound to be able to use something like pen sound. So the team is actually quite important because, as you can see, I'm one of many, and that happens a lot in these kinds of digital projects and computational projects because we are all different. We are different experts in different areas, and one of the things that's particularly important about this project was the software that I'm going to talk about today was created by David Chang for David Enstrom. And David Enstrom is an ornithologist, and he would go out into the field and collect hundreds of hours of environmental sounds because he was interested in studying birds and bird calls. And so David Chang wrote him some software to say, okay, why don't we give you some machine learning software so that you can find those bird calls in your many, many hundreds of hours of recordings, which is mostly just leaves rustling. And so instead of him having to sit there and listen to every single second of it, the machine would say, okay, give me some examples of these sounds, and the machine would go out and search sound with sound and bring those back, just like you would in a Google search if you were looking for a particular term. And Steve McLaughlin is also pivotal in this role as well. He's now a PhD student with me at the University of Texas, but was very much brought up and raised within the context of pen sound and has been really integral in the work that we've been doing that I'm going to show you. So this original institute, and Chris was there. Charles, did you come to the first one? I can't remember.
I went to the one that was at Penn.
Okay, got it. And Al was, Phil Reese was there, Steve Evans was there. And we originally had a mix of people who were had the responsibility of shepherding and taking care of these collections, scholars who were interested in using them in a variety of formats, as well as information studies students and myself and computational research scientists. The collections that we began with, we tried to figure out an assortment of, we weren't working with music, we were working with oral text collections, so pen sound, but also folklore at the Dolph Briscoe Center for American History at the University of Texas, and storytelling traditions at the Native American Projects of the American Philosophical Society. And a note on this, back to Charles's point about distribution, the most sort of progress we've been able to make has been with pen sound, primarily because of fewer restrictions on what we could do with the files, essentially, and what we could share, what we could talk about. And working with pen sound in such an easy way facilitated our ability to go much further with the pen sound collection than we could with the other collections. In fact, we had many Native American scholars and librarians at the original HPSTS meeting where they were telling us the things that they wanted to do, but we were never able to actually ingest into the software those particular audio files because of restrictions with the American Philosophical Society. So that is extremely prohibitive, the lack of distribution and access. And this is another thing that we talk about a lot in digital humanities, the extent to which the things to which we have access shape our ability to do computational research in very meaningful ways. So you'll see a lot of 19th century literary scholars who can do many, many wonderful things in the computational environment, but not much in the 21st century or the 20th century because of copyright. And think about all of the conversations in the literary world that came to light in the context of the 1960s literature, 1970s, 80s, 90s, race, class, all of these things are not part of necessarily the computational discussion at times in the context of text, because those texts are not accessible to us. We can't share them, we can't distribute them. So this notion of access and preservation is very key to scholarship, and the kind of scholarship and research that you might do in the context of a school of information or in digital humanities has a lot to do with these cultural and socio-political questions about to what do we have access, who has access to the tools, who has the means to do some of the things I'm going to show you now. Not everybody. So there's that's a lot of what I'm particularly concerned with as well. These are other collections that were represented. People came who were coming from StoryCorps, which is a huge collection in the United States where people are gathering stories from the community, and they're in a big archive, and now you can just record your grandmother over Thanksgiving weekend and upload it. Oral histories, other poetry collections. These were the people, people coming from the Smithsonian. Everybody was thirsty for this. What can we do? Because if you work in an archive or a library, you understand that these tapes are in some ways, a box that you can't get into unless you have a playback device. And the idea that a person could sit down, listen to everything, precludes their ability as well to distribute things because they're not sure what's on the tapes in terms of copyright, but also privacy. So there's a lot of issues that librarians and archives are working with in terms of why they can't distribute. It's not always mean-spiritedness, but sometimes it is. So for this project, and the project is ongoing, and we've had additional funding from NEH, but I've also had subsequent problems getting funding, primarily because one of the thrusts that I have is this notion of access to the tools. So not only access to the files, but I think that we should be designing sustainable environments and platforms and software that everybody can use, and not just those people that are versed on the command line or with big data analysis. But those aren't sexy topics for funding agencies. They want the new next big thing, which is not necessarily sustainable, accessible environment for people. So one of the things we were interested primarily was to figure out, what do scholars want to do with sound? We spent a lot of time with Penn Sound in long meetings discussing, if we were listening to audio, what would you be interested in hearing? And you saw Charles's list of tone and timbre and pitch, but what does that look like, right, in a sonic file? Like, what is the computer actually counting when it's counting pitch? That's controversial. I mean, we know it's controversial in scholarship, what pitch is or what tone is or what rhythm is, right? Everybody who's done any study in rhythm in poetry knows that over decades, a century, people have been coming up with notions of how you count those things, and then we all realize it's constructed, right? It doesn't actually work. Well, the computational environment, you have to model things very precisely, and we are very resistant to that in the context of the humanities. So what does that look like? Also, what is the computational environment? How do you sustain that environment? It takes a lot of computational power, just like Charles's story with how much storage audio takes versus text. It also takes a lot of computational power to process audio more so than it does text. The computer has to be smarter, in other words. So we also tried to figure out, are there interesting scholarly questions that we can even ask within this context? And then finally, my kind of thing is a freely available API-driven resource that the regular person could use. The librarian or the archive or the scholar who's not well versed in this stuff. Just like distribution allows us to use all of these audio in different ways. distribution of a software platform that's accessible to more people means more voices can be part of the kinds of questions that you can ask with this kind of machine. But there's research questions involved in that too. If you make it into a Microsoft Word platform that everybody can use, you're also closing off other ways of using it to people. So you want it to be user friendly, but you don't want to cut off people's means of making it more complex, of asking complex kinds of questions, which requires some literacy. So that's sort of the backdrop, and the rest of it I'm going to just fly through. So this is one of, Arlo is the tool that David Chang originally created. It stands for Adaptive Recognition with Layered Optimization, but it's kind of a made-up thing. It was actually named after a guy. This is the kind of spectrograph that it creates. To give you a context for the spectrograph and how it works. So it's a heat-based, this is time on your x-axis, y-axis is frequency, and then the colors are based on intensity of heat, or the amount of energy that's created when your tuning fork goes faster or slower, that kind of thing. That's as complicated as I'm going to get with you today. This is an example of 3 different recordings of Some Such Thing from Gertrude Stein's The Making of Americans. And you basically have a representation here of 3 voices. On the left, you have a computer who has read some such thing and is saying it out loud. So text-to-speech software, and then we captured it as audio and show you the spectrogram. You have Stein, a recording from Stein, saying some such thing. And then you have Gregory Lehner, who apparently was drunk and was, I think that's true, right? Like, but I think the idea was that, I mean, I don't know, how many people have read The Making of Americans? Yeah, me. Yeah, like 5 of us. It's hard to read, right? So apparently the story goes that he decided he was going to read the whole thing out loud based on, I think, performances that you all used to perform in the New Year's Eve for many years. And it takes about 24 hours to read the whole thing, I believe. And he decided he was going to read it, but it's so repetitive that he decided he had to get drunk. So this is him actually, he's singing that part.
It's all on pen sound. Right?
It's all in pen sound, exactly. So this is a computer, some such thing. This is Stein, some such thing. And this is Lehner singing them. So you can see it looks different. They're the same words, but audio, in terms of the audio and the spectrogram that's created there, they're very different. So in something like Arlo, you get your spectrogram, and then you get a page like this, which allows you to kind of change the spectrogram around. You can pull the frequencies out. You can change the damping factor. All very technical things. And so it might look something like this. Like if you had 128 frames per second, this is the same piece of sound, but this is stretched, the bottom one. This is 500 frames per second. So this is at 41 seconds, that's at 42 seconds, that's at 41 and 42. So it's basically zoomed out. There's just more data in the frame. I think everyone can see that in the example. The same happens here. This is the same, this is the same audio example, but we've changed the damping factor. And the damping factor is basically equivalent to how sensitive is your tuning fork. Like if it's really sensitive, you're going to get lots of tones and harmonies. It's going to react to a lot of things. But if it's dumbed down, then and you might make it really sensitive if you're interested in harmony, or if you're interested in pitch. You might make it really dumb if you're just interested in rhythm, because then it's just responding to those hard beats. So you can see it sort of changes the picture, which means it's changing the data behind it. This is damping factor and gain. These are all things that an engineer would know more about, but it becomes significant if you're looking for certain kind of properties. If you are more interested in harmony and tone than you are in rhythm, you would rather have the data representation that you're going to then use to search for sound actually have that kind of data represented there as opposed to the other kind of data. You come in, you mark your sound, you say, okay, this particular one is English. This is a recording. It's not been cut up at all, but I've created boxes around particular kinds of sounds. What you have here on the left is English, right here in the first box. Then the speaker switches to Ojibwe. He switches back to English. He starts playing the drums, and then he's chanting or humming or singing. And you can see those kinds of differences. But as a scholar, I might be interested in those kinds of shifts in sound. And so I would want to be able to mark them so that then the computer could mark them for me once I give it enough examples. So, and then the computer divides up all the files. It creates a model for those people who care about machine learning for, sort of frames across there. It takes a whole bunch of those numbers and data points behind it. Think of this as basically behind the spectrogram. This is what's back there. And then you basically give it an example of a snippet of sound, and then you ask it to go find more like those. So I'm gonna show you a little example here in the next, I think it's on here somewhere. Where am I? Okay, here it is. Here's an example of me doing this, a really, really simple example that some of you have already seen before, but it's very simple. I'm gonna turn it up. So this is a catalog of audio in Arlo that has, I should set it for you first, hold on. No, where's my, now I'm confused. Okay, sorry. This is a catalog of audio where I've taken about 15 recordings. I put in 3 different recordings of William Carlos Williams reciting This Is Just to Say, and some other recordings. And I give the machine a little snippet of William Carlos Williams saying, "Forgive me," and then I ask it to go out in the rest of those recordings and find the other ones, fully well knowing that there are other recordings in that collection. I've stocked the pond, which is a way of saying, I put all my fish in there before I go fishing, right? Okay, let me see. And this is just an example of, so this is the screen you just saw. I gave it the green one, it gave me all these red ones back. This is the original recording that I used.
This is just to say, I have eaten the plums that were in the icebox, and which you were probably saving for breakfast. Forgive me. They were delicious, so sweet, and so cold.
So this is,
Forgive me.
I snipped that, right?
Judgment.
It came back with Allen Ginsberg saying judgment.
Brooklyn.
Came back with Allen Ginsberg saying Brooklyn Act.
Forgive me.
And then we finally got another forgive me. Now, you may be sitting there saying, oh, poor thing, like she's showing us this and it doesn't work, that's awful. But in fact, it's working on the sound, right? It's saying forgive me, Brooklyn acts, judgment. It's looking for other things besides the words that they're saying. It's got those, they do have audio similarities. Now, this isn't the best example. It's not as close as you would want it, because with big data tools, you have to have a big collection. You have to have a lot of examples. And that's one of the things that is prohibitive in terms of access to these kinds of situations as well. Without a big collection like Penn Sound, if it's just a smaller collection, these kinds of things don't work as well. So it also does things like clustering. So you can give it, it'll cluster certain kinds of sounds together as a discovery phase, for those of you who means something. So I want to show you a small project of something that I did with Steve McLaughlin. We were looking for applause in Penn Sound. As of May 15th of last year, we took 36,000 files. So it sounds like there's more files than there were even then, or 6,200 hours. We did some deduplication, so that's a pre-processing phase. So even in the context of computational environment, there's a whole bunch of things you have to do to files first before you can do anything with them, and you have to have the wherewithal in order to do that too. It's just like if you were asking a literary question, the more knowledgeable you are about the scope of the space and the context of the literary question that you're asking, the more productive you're going to be in terms of contributing to that scholarly environment. It's the same thing in a computational environment. You have to know the steps you need to take first before you can actually get to any place with it. We took 3 second examples. We cut down to about 2,000 files, and we got 274 examples of applause and 582 examples of non-applause, because you want to give the example a positive example, the machine a positive example and a negative example, because you want it to say, listen machine, you're just deciding between these two things. Is it this bird call or is it a non-bird call? Meaning, is this a bird call or is it noise? And then it classifies from there. So, and then we predicted about 2,000 files. So this is what, let's see, I'm not going to play that for you, but this is what applause looks like. That's an example of applause. It's pretty easy to see. And if it's something that's easy to see, it's usually going to be something also that's pretty easy for the machine to figure out. If it's muddled in there as something that looks just like anything else, it looks like just like anything else to the machine as well. It has to be something that a human can model for the machine first before a machine can do it. And so think about the intellectual work that requires. Asking your students, imagine asking your students or your fellow colleagues to tell you what, they listen to an audio file and to tell them why that particular phrase is more meaningful than another phrase. I mean, these are direct human interpretive behaviors or examples. So then it takes time frames every half second, and it gives you a prediction about whether that half second has applause in it or non-applause, and it goes through the whole file and it does all of that. And that's how you end up with big data at the end. And I'll show you some visualizations next. So I want to show you the examples of the data in the context of why would you ask this question in the first place. Applause is a delimiter between readings. So one of the things that we notice, what you see here is the y-axis is probability. So this is that chart you just saw where across the time frame the machine has said, I predict there's applause here. The machine has predicted that this is non-applause basically all the way through. It's very low on the prediction of applause, and then you see it at the end. And you see this pretty consistently across multiple recordings. So these are multiple recordings from Penn Sound. You see this kind of pattern repeatedly at the end. So it shows us, okay, this seems to be working well, right? These are people clapping at the end. Applause is a delimiter between introduction and the start of a reading, which is very interesting as well, because maybe if you want to figure out what someone is saying in the introduction, but it hasn't been snipped out or it hasn't been put into the metadata for that file, then you could do a visualization of all of it and say, oh, look, there's these long introductions in some of these. This is where I want to start my research. Okay, these are discovery points for where you might start to ask the questions that you might do in a very traditional way, in the way that you usually do, but it's a starting point. It's access into these audio files that maybe we've never had before. And they tend to repeat over time. Another thing is, individual recordings on a compilation, or a person has all of these recordings, and then you say, oh, well, this, the prediction is really high in some spots and low in others. Maybe that was a particularly good poem, and the audience is very responsive. So those continue on. So you can also use it as a delimiter between poems of a particular speaker, if you wanted to. Who gets longer applause? If you have a compilation of people, apparently this poor guy did not do very well, right? Or woman. I don't want to be sexist here, but usually women are better poets. No, I'm just kidding. And it goes on like that. So you can see these kinds of things. Also, one thing that we started to see was this, which was very interesting to us, because we thought maybe, Steve and I thought, oh, wow, this must have been a really great turn of phrase here, where the applause, there's people just, how they do in poetry readings, just stand up in the middle, and they're like, that's a wonderful line. No, that was actually applause and then question and answer afterwards, which is very important for cultural, sociopolitical questions about what is the audience like to whom this poet is speaking, what are the kinds of questions that these people would ask in this day and this time in New York City in 1965, where the poet is maybe saying something that could be controversial in terms of politics, etc., or Trump. So, are there mistakes? Yes, there are mistakes. It saw strong hiss as applause. It dissonant music as applause. Bagpipes, definitely applause. So this is up there as an example to the extent to which computers are wrong. They are not perfect. And we, as a scholarly community, have to get comfortable with that as a first step. An imperfect first step in an environment can allow you points of discovery, but at the same time, the exactitude is still your responsibility. The machine's not going to give you that. So we started to ask some interesting questions, and I'm gonna finish up. But we wanted to say, okay, well, if we actually took the statistics of the site and started asking questions about, do poets get longer applause if they're men or women, or are there differences based on the decade or age, or regional or venue specific? We started to ask these questions: men and women, not much of a difference; years and location, not much of a difference. But we pretty much decided these weren't actually very good questions. I mean, that's the other thing we talk about in digital humanities as well. What is a good question in the context of this environment? And one of the things that we found was a problem with this kind of question was that these venues are very different, right? You can have the same reading at different venues, and so applause is going to mean different things in those different spaces. The readers are very different for different occasions. The audience may react differently at different times. And what about culture? Looking at a single venue or speaker may not give a consistent picture of the audience dynamics at a place. So what did we do? We went back in and we said, okay, well, what is representative of particular cultures and audiences? And we regrouped the data according to reading series, primarily because the reading series allow for a particular kind of context, typically a particular kind of audience, and we could then say things about, well, this sort of behavior seems to happen within the context of these particular reading series, and we were able to make some differences there. And one of the things that we noticed was the Belladonna series got significantly less applause than some of the other reading series, and people are laughing, and I think they know why. It's a different context, right? Some of the other reading series were language poets, there's frivolity, there's fun, and then you get to the Belladonna readings, and in many ways they're very political. It's a different kind of context, and you can make some readings or assertions from there, which I'm not going to do right now. But again, this is a discovery point. Once we made this sort of discovery, we started to do a little bit more, and Steve and I published something on this work in a new online journal called Cultural Analytics. And you start to then make assertions about what's going on, but you have to be very clear, like Chris was saying, on the context of how you're doing the computational work, how are the recordings done. All of these things factor into the kinds of assertions that you can make in this context that we have sometimes forgotten to talk about in the context of text, because we think, oh, it's in a book, and that book was published in 1930, and you just take that as a fact and you move on, right? But people in bibliographic studies, they actually care, not that you don't care, or most people don't care, but they care in particular about what did that book look like on that day to that audience. So just as a very brief conclusion, some of the things that scholars talk about: language dynamics, tempo, pitch, environment. You heard Chris talk about that. Materiality, recording noises. Some of my folklore people cared about bird calls and chickens and train whistles. What do engineers talk about? They're talking about bit depth and signal processing and dynamics. Computer scientists are talking about features and ground truth and optimization. So you have all these communities coming together with their different research concerns. It's a very fruitful environment, but it's not necessarily just the literary concerns that are at play. So finally, these are the kinds of things that I think our future questions are, which is sustainability, literacy. I saw all his eyes sort of blank over when I had that page up with all of the technical things that you had to choose in order to do some of these things. Accuracy is good enough, and scalability. Can you do it on your computer, or do you have to have a supercomputer, which we were able to have access to? And finally, sustainability, preservation through distribution. Who gets access to this kind of method? Into the kinds of collections that we're talking about, but also these kinds of methods. Who gets to have a voice in that space? Thank you.